end-to-end linked data with minimal computing with Minor Gordon, who is an independent software developer and is going to talk about this topic. So over to you, Minor.
Thank you. So this is a joint work with Arden Kirkland, who's a librarian at the Syracuse High School. All right, so a couple of goals for this talk. I'm going to survey some software that we developed. It's called Paradigms, a framework for generating websites of various kinds from linked data. And I'll share some lessons learned. My main goal for this talk, though, is to encourage you to try alternative approaches to incorporating linked data into your projects. So this is definitely an alternative approach, particularly for small GLAM institutions, and also consider ways that linked data can improve your end user's experience. One particular non-goal of this project, however, or this talk rather, is to convince you to use the software. It's a vehicle for experimentation. We've been working on it for a few years now and are presenting this as a sort of lessons learned talk rather than trying to sell a product as such. All right, so just unpacking the title a little bit. What does end-to-end mean? So end-to-end linked data with minimal computing. What do I mean by end-to-end? Well, I want to start with RDF as close to the source as possible. So if we have RDF, say a linked a linked art API, then we'll pass that through. And for non-RDF data sources, which we'll see in just a moment, we'll translate those to RDF, typically using something like JSON-LD to get them into linked data as quickly as we can. And then we'll pass that all the way through the system. I'll show you a system architecture diagram in just a little bit to the user interface. So this differs from a lot of approaches that have the user interface consuming something like GraphQL or JSON or something like this, where you don't really have RDF in the end user interface. This actually uses JavaScript to manipulate the RDF in the GUI, and there are pretty good reasons for that. Linked data. So Arden and I have had a lot of discussions around what makes a data set rich. And in particular, we've identified that it's not the nodes and it's not the quantity of the nodes, it's the density of the links between the nodes, and in particular, what you can do with those links. So I think everyone here has probably seen RDF, which is not really linked data. So this is just an example I pulled off, ironically, from a W3C tutorial of some kind, where they had an example location pointing to the string New York. That's definitely not what we want. We want these links to be represented all the way to the user interface. And in particular, what we see repeatedly in manipulating the data is that reusability requires intention and effort. So there tends to be, there's a tendency to think that reusability will just fall out of projects of various kinds. And having tried to actually reuse other people's data, we are primarily using other people's data in this project. That doesn't actually happen. So you don't necessarily want the linked data consumers to have to do a lot of work to make use of your linked data. What is minimal computing? This is a pretty common term that's or has become that way. But particularly what this means for this project is we want to leverage open source freemium cloud services, so Google Sheets, Airtable, GitHub in particular, and use static site generation. So I know a lot of the minimal computing discussion has come around static site generation. There's links within the talk. I've uploaded the slides also as PDF. This link is to the libstatic methodology. So a lot of the inspiration for this project comes from Collection Builder at the University of Idaho, rather than there's some points of differentiation. So they use CSC predominantly, for example, whereas this is more RDF based. The ideals are the same, essentially, though, in that we want to avoid lock-in to specific technologies, and then particularly proprietary technologies. So focusing on the framework in particular. So how did this all get started? Arden and I met after she was lead author on an article about sharing historic costume collections online. Arden's background is in costume design initially before she went back and became a digital librarian. So her background really lends itself to bridging the museum and library worlds, as well as costume interests. I am married to a fashion historian, so I wanted to find out more about this. I saw this article in my wife's professional journal and contacted Arden, and thus started this collaboration around libraries and museums. And in particular, we're really interested in the potential for linked data to help small GLAM institutions. I think some of this tends to get overlooked. So how are we going to do that? Well, here's the system architecture diagram that I promised. So it starts like with the data sources over here, Google Sheets, Excel files, Markdown, YAML, and so on. I used to support Omeka Classic. I know that's being phased out to some degree now. I intend to support Omeka S there. And then using GitHub Actions to essentially do extract, transform, load. Going back to the previous slide where we had RDF transforms. If you start with Excel, obviously you're not got native RDF there and recognized syntax like turtle. So you're going to need to do some sort of transformation there. But for things that have native RDF, for example, the enrichment from Wikidata, that just passes right through to the static site generation. And then finally, this static site generation generates a set of HTML, CSS, JavaScript pages, as well as the RDF data. So this is the big crux of this. This approach is really only appropriate if you can pass the data through at build time of this interface. So it's not going to work for highly dynamic databases. It won't work for huge databases at all. It's primarily designed for small GLAM institutions. I will say that a static site generation with tools like Next.js and Jekyll has gotten good enough that the data per page load is not that big as a general rule. The obvious exception are things like search pages, which do require access to the entire data set. Along the way, sometimes there's enrichment. I'll talk about that in another slide a little bit via ALSAMAS. So what do these inputs look like? The idea here is that a GLAM institution, a small one, is not going to necessarily have access to triple stores, server machinery, and so on. So we'd like to make the inputs simple while also avoiding lock-in. So what we have here is a standard Google Sheet, and you probably recognize that as JSON LD. So this is the IRI identifier there with namespaces and using data validation in Google Sheets to link to other sheets. So pretty basic. You can't do deeply nested blank nodes here, for example, and it's encoding some assumptions about the data. For example, that your end date is an XML schema date and not a blank node. But you can actually, the parser for this that does the translation will actually parse arbitrary JSON. So technically I could insert some JSON LD in there, but typically just use it with dropdowns and so on. Equivalently in Markdown, so this is a pretty similar, as you see here. You can put this in a file and then treat the header. This is obviously modeled on Jekyll. Treat the header as the JSON LD, and then essentially just slot all of the heading text into a field typically called description. Another is Airtable. So Arda and I worked on this together. She has a vocabulary called application profile, sorry, Arden, called custom core, which is a combination of the array core, Dublin core, and some custom predicates for describing historic custom in RDF. So she actually defines this vocabulary in Airtable, has a certain structure, objects, names, images, and so on, control vocabularies. And then the paradigm system will essentially take this format and generate various interfaces from it. So I'll show those in just a moment. These are the inputs from this system architecture. So we looked at Google Sheets, Markdown, Airtable. Excel is pretty similar to Google Sheets. What does this extract, transform, load do? And finally, like I said that we're going to consume RDF in the user interface. How does that actually work? Typically, when you have this type of system, you're taking all of these inputs. You may have, a library system of some kind, or a museum, a collection management system like Past Perfect here, or so on. To do this extraction from load, typically what you would want to do is transform them all to a target data set, or target data model rather. That would be a logical data model like linked arts. I saw a presentation a couple of weeks ago from the team at Yale, and that's what they do. They transform everything to the linked art model, which is excellent if you need it, right? But This is actually a little bit more ad hoc. This is essentially saying, well, rather than try to translate everything to one data model, I'd like to be able to reuse as much data as is, which is a little bit different problem. So I'd like to be able to take, in particular, Dublin core data, Creative Commons RDF, FOAF, schema.org, Wikidata, and linked art eventually, and VRA eventually, RDF of various kinds, and all use them all in the same user interface without translating any of them to some other model. So how am I going to do that? Well, obviously I could translate them to some other model, right? So all of these you could probably retranslate to linked art if you were going to restrict it to the GLAM concepts. But another way of approaching this is to use standard software engineering practices to put a layer of abstraction over all of those abstractions, or all of those concepts rather. So what I did was essentially go through and look at all of these data sets and see commonalities between them, right? All of these data models rather, see commonalities between them. So they all have some concept of agent, right? In schema.org, that's an organization or a person. They have concepts of collections. So you see that in Dublin core and schema.org, a concept in SCOS, right? As well as defined term in schema.org, event, images, licenses, and so on. A lot of GLAM-related data models will fit into this general category of conceptual data models, right? So we can actually define that in the user interface. This is some TypeScript as a high-level domain interface, and then implement it, do the mappings in the end user interface at runtime rather than doing them ahead of time. So rather than do RDF to RDF mappings, all the RDF passes through as is. Wikidata, for example, passes through as is and then conforms to this interface. So this is a Dublin core one, of course. This is RDF JS based, those interfaces. And it does those mappings to fit the interface at runtime. I won't get too far into the coding aspects of this, but there's a blog post about how all is implemented. So how is the enrichment done? So this is how to consume, essentially how to consume things in the user interface, mapping RDF to things that the user interface is going to use. How is the enrichment done? So that's this part of, this diagram. So when the data is coming through into the ETL GitHub action, this is going to pull any al same as references into that RDF and add them to the data set before it's passed to the static site generation. How does that work? Well, essentially just pulling all of those things in, see the al same as reference, resolve that RDF, translate it minimally as needed. I would like to thank the people at the North Carolina State's University Libraries, because they embed schema.org for all of their collection data, which is a nice thing to be able to test. That is a resolved, this is from Wikidata actually, that's I wish that Wikimedia Commons export RDF also, but instead I used the API and translated it to schema.org and emitted that for downstream consumption. On my to-do list here are Getty linked arts, Yale linked arts, and Met Open Access CSV. How does the GitHub Actions bit work? Well, GitHub Actions, don't have too much time to go into this in depth, but it is a continuous integration deployment system that runs automatically when you push to a GitHub repository, or you can manually trigger it or schedule trigger it and so on. So this is effectively the code to chain together the ETL action given the spreadsheet here, and then do the static site generator. So just incantations there. What does this look like on once it's all published? So this was chain ETL from the spreadsheet, translate the spreadsheet with JSON LD to RDF, and then put the RDF into the static site generator, and then upload that to GitHub Pages static sites hosting. What does this look like? Well, the strength of this is that having this conceptual data model, for example, is that you can support many, many different kinds of interfaces using this basic structure. So why go to the trouble of having these sorts of abstractions of different kinds of licenses, different kinds of works, different kinds of properties, and so on? Well, We'd like to be able to incorporate data from many different sources, particularly if you're a small grant institution, right? So you don't want to reinvent all of these things. So we'd like to be able to pull in all of that data and then generate some interesting interfaces in conjunction with our data. So here's one standard digital exhibition type of application using images, people. You can see here, unlike some of the big museum library systems, attribution is a pretty big consideration here. So pulling in the image license, right statement, and so on, and adding those to the various images, and then having a similar people tab there. This is the description that you would see in that Markdown file earlier. A timeline app. So this is based on that spreadsheet that we saw earlier. My wife's a fashion historian, put together a small spreadsheet as an example data set to show fashion history exhibitions. So this is basically taking the image, schema.org event, license, and people that organize the fashion history exhibitions into a timeline. Work search. So this is probably where I've put the most coding time in. This was originally all based on Arden's work on costume core. So taking standard works from the Vassar College costume collection primarily, and putting them into a faceted full text work search interface. So the thing that I particularly like about this is the visual facets. So this is, of course, image, work, license, rights statements, and then these are all properties. So either an RDF property or a schema.org property. And then these are SCOS concepts with images depicting them. So when you open up the filter, then it shows the concepts and the controlled vocabulary. That's pretty important for novice searchers, catalogers, which leads into this. This was actually our original project, and Arden presented this at LD4 a few years ago to do the opposite of this. So this is the search interface with the controlled concepts. Right? This is the cataloging interface. So rather than building up, having properties, concepts to do searching, you can build up a record description with the properties and concepts. So that was all for the paradigm survey. Just a few lessons learned that we've some of them learned the hard way as we went along. I have a software engineering background, so I went to grad school and studied building fast things, and I was not a user experience person, user interface person when we started out on this, and I learned that that is not a great way to approach linked data projects because you quickly get lost in how to accumulate nice RDF, and that's not really useful. So we actually realigned a few years into the project and thought, well, why are we doing this? Well, we would like to help end users ultimately, and the end users don't really see your RDF, or probably shouldn't see your RDF. So how are we going to make user interfaces which are engaging to them? The fact that we use RDF is really, it's nice for us, but ultimately what can we do with that to help end users? I think there is some emphasis on this, but I haven't really seen enough. I feel like we have a lot of rich data, but not a surplus of interfaces that make great use of it. I saw a talk recently on the knowledge panels, the linked data for production work at Cornell and Stanford. And then, of course, the one I mentioned on Yale, which was really good as well. They're using essentially ego graphs. So it doesn't look like a graph, but essentially having individual pages for different node types in a property graph, essentially. And then the semantic computing group in Finland does some excellent work with semantic portals. Another thing we found related to this is that one size fits all user interface is not as engaging as a lightly specialized one. So there's obviously a temptation to shove everything into a search interface of some kind. And I understand that. But at the same time, it's really tricky to get other things like timelines or exhibition-like interfaces in that. I think the Yale group has done a really good job of that in the sense of having specialized interfaces per node type, per object type within their interface. That's typically a pretty difficult thing to pull off. So another thing that I found looking at all these data models and considering sort of the conceptual data model to encompass them is that we have more than enough general purpose data models already. So this is just a few of them. Obviously, there are many, many more. Dublin Core, of course, everyone's familiar with as the lowest common denominator. It doesn't work so well as a sort of organizing principle, the structure there, but it's worth supporting as well. Linked Art, I've mentioned a few times. I've recently switched, within the last year, switched to schema.org as sort of the go-to format because of ease of authoring. If you're going to support spreadsheets, schema.org is much friendlier than Linked Art, for example, which has a lot of nesting of blank nodes and so on. And then Wikidata is a common reference point for doing same as and enrichment. The accompanying point is that we have a lot of data models, but if you pick any one of those data models, the support for them is not as good as, or not as comprehensive, we'll say, as what you would find for a common API in an enterprise setting, for example. And I think that that's unfortunate because there's so much richness and so much thought there that that is going unexploited because of lack of documentation and examples and so on. So I would say that I'm coming from a background where I don't mind reading the RDF and so on, but I think that that is excluding a lot of people. What I'd like to see is things like comprehensive documentation. I won't say that my project is some sort of epitome of this, but I've tried to follow this documentation system, which I find pretty useful. Most documentation in this space tends to be more information oriented and less about how to use recipes and so on. Another thing that would be really useful for me, as well as to a lot of other people, I imagine, are things like demo applications and example data sets. These are pretty common also in industry enterprise settings, but it's makes life a lot easier if you don't have to stare at the data and figure out how to map that into a programming language. Paradigms, actually, I mentioned started around 2015, and it started in the way that I knew how back then, which was to build heavyweight enterprise systems. So that's kind of where my background is. A lot of moving parts, those ETL pipelines doing asynchronously, having triple stores, middlewares, and so on. Used all sorts of exotic Scala and functional languages and so on, just to have fun with the technology. But such a system doesn't last. So it has too many moving parts, and ultimately, even very well-intentioned designs, like here's the semantic computing lab, they're not answering their URL error anymore, and that's all too common, unfortunately. So we really switched gears over time to focus more on thinking, I guess, in the small, and thinking about, well, what can we really do with purely sustainable parts, these minimal computing approaches. I think it goes beyond, as you've seen from the interfaces, I think it goes beyond what blogs and kind of classic websites, and you can do a lot now with things like Next.js, which is React-based. You can build full interfaces in that, and not just more static HTML. This also requires intention, however. Like, we could have sort of drifted along with the triple store approach, and I think it would have been fine. But starting from this design, it requires optimizing for a completely different set of constraints. And then finally, design for the user experience. So one thing we realized, we started out actually thinking about union catalogs for custom collections. If you look at that article that I mentioned earlier, sharing historic custom collections online, one of the things that it calls for is a union catalog. We started looking at that and thinking, well, how can we accumulate large quantities of data with ETL and so on? And we actually figured out that most of the data we could accumulate was not that rich. And that because it wasn't rich, we probably weren't going to be able to make a great user interface out of it. So we actually pivoted then around and said, well, what would a really rich data set look like? Let's start with that as an assumption that we have a rich data set. We'll make a small data set, that is multiple small data sets that are really rich, and then see what we can do from a user interface perspective with that. And as you can see, for example, the Mitchell Whitelaw generous user interfaces and Olivia Vane's work in visualizations, you can do a lot if you have a rich data set. So I would advise you to encourage you to prove that your ideas work in this way. So thinking about the ideal and then sort of backing into it, into the user interface from there, and then having progressive relaxation of that, right, for other user interfaces. Right, so there's the website. This is all linked in the slides, of course, and you're welcome to contact me on email or Slack. Are there questions? I think I have 3 minutes.
So this was awesome. There's mostly lots of enthusiasm and agreement and heck yes for a lot of these points, but there were a couple of questions. So one of them came from Crystal. And so is there a place where we can find up and running interfaces with test data sets in Paradigm so that we can check out what sorts of features it offers without using it on local data?
Yes. So if you'll grab the slides, I think that they survive the PDF.
Yes.
So I attached them to the presentation. I think the links survive the PDF conversion, and all of these headers, for example, link to either the inputs, so that's linked to Airtable or the spreadsheets and so on, and then the interfaces. So like
fantastic.
Mm-hmm.
Great. I am checking if there's more questions. I think the only other question was for me because you touched briefly on user research and UX. I was curious whether you had gotten to do any user testing with this and or gotten user feedback in any other way, and if so, what was it?
We did some user testing on the worksheet app because it was the earliest one that we developed, and I will say that a lot of people said we need to have all of the images before it's useful. So unfortunately, something with like cataloging, for example, it's not useful until it's comprehensive, right? Until you have every possible option. So that was part of the awakening of, well, our data is really nice, but our user interface is not everything that we hoped it would be. Yeah, we have done some user testing.
Cool. Okay, so I think that's all. There's lots of comments, but no other questions. So Callie, if you want to close us out.
Okay, great. Thank you so much, Maya. This was a fantastic presentation. We'll see everyone for linked data challenges from Mark 21 to LRM